Welcome to this explainer. Look, as senior engineers, we're all seeing this massive explosion of AI coding tools right now, right? But there is a very clear divide emerging in the industry. Today, we're going to break down exactly how top-tier engineers actually manage AI agents. We are officially moving away from amateur guesswork and diving into a professional, highly structured workflow. Basically, we're going to learn how to manage your AI exactly like you would a highly capable yet very junior developer. Let's jump right into the core difference highlighted in the source material, which is abandoning what people are calling vibe coding in favor of strategic orchestration. Vibe coding is essentially amateur guesswork. It's throwing open-ended, lazy prompts at an AI and just crossing your fingers, praying it doesn't hallucinate your entire backend from scratch. Honestly, it just results in unpredictable chaos. Strategic orchestration is the exact opposite. It's treating the AI with strict rules, providing deeply localized context, and actually managing workflows using professional tools like Git work trees. So, here's our management handbook for today. We're going to cover standardizing behavior, assigning roles, managing parallel sessions, troubleshooting, and finally, executing emergency rollbacks. Let's get into it. Okay, Section 1, standardizing behavior. This is all about setting the guardrails for your new AI intern. You know the pain of having to type out use TypeScript and Postgres for the millionth time? Yeah, let's stop doing that. To standardize how your AI behaves before it writes a single line of code, you need to categorize your rules. You apply global standards across all your projects. Things like your overarching testing philosophy, preferred libraries, and core coding standards, and store those in your main tool drive. Meanwhile, you keep the highly specific stuff, like your exact tech stack versions, database schemas, and branch naming conventions, totally isolated in repository-specific files. Boom. Now every AI interaction automatically knows your preferences. But beyond just the rules, you absolutely need context. By establishing complete code-based context right out of the gate, literally indexing your entire repository, your AI knows exactly what it's looking at. This ensures the agent is starting with your existing architectural logic, rather than just hallucinating a structure from scratch. It instantly removes a massive margin for error. It's like handing them a map before they start driving. Moving on to Section 2, assigning roles. Let's talk about the multi-agent pipeline. Once you've got prompting down, you can start deploying specialized roles, where multiple agents work simultaneously on the exact same task. Agent 1 writes the initial code. Then, Agent 2 steps in to review that code and provide critical feedback. Finally, Agent 3 writes tests based on the implementation and the review. Instead of letting a single AI just, grade its own potentially flawed homework, this pipeline forces fresh context and a completely new set of eyes onto the problem, which drastically increases your output quality. But here's the crucial takeaway. This is collaboration, not delegation. Even with 3 agents running, you are still the human in the loop. Think of it as pair programming on steroids. The AI won't judge your variable names, but you absolutely must manually verify everything. You have to read the code, read the tests, and dive into the architecture yourself to ensure it actually meets your senior engineering standards. All right, Section 3, managing parallel sessions. It's time for orchestration at scale. If you really want to scale up your output, you can run different AI sessions in parallel by creating separate Git work trees. You set up these parallel checkouts and just seamlessly switch between AI sessions to approve or deny operations as they progress. The source material actually likens this to chess grandmaster Magnus Carlsen playing against 20 people at once. And to speed things up even further, you can operate Git in natural language. Just tell the agent, hey, create a release branch and cherry-pick the fixes, without ever having to memorize complex command line flags again. Now, because orchestrating multiple agents across different work trees can get overwhelming pretty quickly, it is vital that you define clear criteria in your tooling. You've got to set up strict permissions checks, define exactly which tasks require your explicit human approval, like complex architectural changes or, heaven forbid, database migrations, versus those tasks that are safe enough to run via autonomous execution, like routine unit tests or isolated UI tweaks. To ensure these parallel tasks stay strictly on track and don't just obliterate your API budget, you must use contextual anchoring. Keep your conversations short and highly focused for each individual task to save tokens. Seriously, don't make the AI guess or search the whole codebase unnecessarily. Highlight and attach specific code files. Got a UI issue? Upload a screenshot. Need a specific integration? Drop in the exact API documentation URL. Concrete context equals concrete code. Which brings us to Section 4, troubleshooting. This is where we start code reviewing your AI. During the code review phase, treat your AI exactly like a junior developer whose code needs a thorough, meticulous senior review. Never blindly trust the output. When the AI delivers a feature, push back. Directly question its logic. Ask it, hey, why did you choose this pattern? Or what are the error cases here? Or how does this actually impact performance? Questioning the AI helps you understand the why behind its implementation, just like you would probe an intern during a peer review. So let's look at this definitive troubleshooting checklist. It completely empowers you to aggressively vet the AI's logic. You question the architecture. You check edge cases. You review the performance impact. But here is the most important part. Manually jump in and edit the code yourself when you see something wrong. Once you make your changes, you can literally force the AI to refactor the rest of its implementation around your manual edits. You always remain in total command of the codebase. Finally, Section 5, Emergency Rollbacks, because sometimes we have to revert AI logic errors. Sometimes, despite all our guardrails and rules, the intern goes rogue. If multiple agents start generating chaos and you suddenly realize you're losing control of the architecture, don't panic, but do act immediately. Follow this exact step-by-step emergency process. Step 1, pull the plug. Stop generation immediately. Step 2, revert the task entirely. And Step 3, check out your last known working commit. You have to know when to cut your losses rather than letting the AI dig a deeper hole in production. This quote really hits the nail on the head and encapsulates our entire philosophy for this explainer. AI won't magically make you a 10x developer out of thin air, but it will massively amplify your existing engineering judgment. It removes the tedious pain points, sure, but you are still the architect. You still need to know what good code looks like and understand the reasoning behind every single merge. As we wrap up this explainer, I really want you to ask yourself, how are you going to structurally onboard your first AI intern today? Think about how you can use the specific frameworks we just covered, setting up global and repo-specific rules, assigning specialized roles across a multi-agent pipeline, and spinning up parallel Git work trees to truly regain strategic control of your codebase. Thank you so much for learning with us, and I can't wait to see you in the next explainer.